Hello, I'm Susobhan Ray. Currently, I am working as an assistant professor in EC department of Swami Vivekananda Institute of Science and Technology. Uh, Today, I am going to discuss the pin configurations of Intel 8085 microprocessor. Here in this diagram, we can see this is basically the schematic diagram of Intel 8085. Uh, this is basically describe the various pins and their functions are as follows. If we focus this diagram, we can see that there is some addresses and data buses, and there are some control and status signals, and externally initiated and interrupt signals are also present there. So what is addresses and data buses? A8 to A15, these are basically called the output pins, which are representing the MSB, most significant 8 bits of memory address and the 8 bits of the input output address. So these are the basically address buses and are used for MSB, that means the most significant bits of the memory address or 8 bit of input output address. Next, 80 to 87, these are the input and output pins, and here you can see that the address and data both are in multiplexed form with address and data bus. That means they serve dual purpose. Okay, they are used for the LSB or the least significant 8 bits of the memory address or the IO address during the required clock cycle or of a machine cycle. Next, there are some control and status pins. For example, ALE, which is known as the address latch enable. This is an output pin. Whenever it goes high during the clock cycle of a machine cycle and enable the lower 8 bits. In that case, it will enable the lower 8 bits of the address to be latched either into the memory or some external latch. Read write, these are the control signal. Next, IO/M. Okay, this is basically the output pin. Whenever it is goes low, the address on the address bus is for memory, and whenever it goes high, then the entire operations will be IO device related. That means the address on the address bus is for input output device. S0, S1, these are the status pin. These are the status signal sent by the microprocessor, okay, to distinguish various types of operation. Whenever both pins are 0-0 condition, that means the operations will be halt state. Whenever it will be 0-1, then it is write operation. 1-0 case, it is in read operation. 1-1 case, it is in fetch operation. And there are also some other control and control signals are also available. For example, X1, X2. These are the input pins. These pins are connected to an external crystal oscillator which drives an internal circuitry of the microprocessor to produce suitable clock for the operations of the microprocessor. Clock is nothing but this is an output pin. It is clock output basically for the user, which can be used for other digital ICs. Okay, and reset in, reset out, these pins are externally initiated by some device. Reset out is obviously this is an output pin. This is indicating the CPU is being in reset condition, and reset in is the input pin. It is basically resets the PC or the program counter to 0. Next, in this slide, here we have seen that there are several kind of pins are also available. One is called hold. This is an input pin. It indicating that another device is requesting for the use of the address and data bus. Whenever the hold request, the microprocessor is relinquishes the use of the buses as soon as the current machine cycle is completed. Then the processor regains the bus after the removal of the hold signal. Okay. Next, the HLDA. This is acknowledge the hold request. It is the signal for hold acknowledgement. That means it indicates the hold request has been received. After removal of the hold signal or the hold request, the HLDA goes low. Next, INTR. INTR is an input pin of 8085 microprocessor. It is an interrupt request signal. Among all interrupts, it has the lowest priority. When it goes high, the program counter does not increment the content. Okay, the microprocessor basically suspends its normal sequence of the instructions. So after completing the instructions, it attained the interrupting the device. The INTR line is sampled in the last state of the last machine cycle of an instruction. The microprocessor acknowledges the interrupt signal and issue INTA signal after receiving the INTR request. Okay, so that means the INTR is basically enabled or disabled by the software. An interrupt is used by IO device to transfer data to the microprocessor without wasting any time. If CPU is in hold state or the interrupt enable flip-flop is reset, an interrupt request is not honored. And INTA is basically, this is an interrupt acknowledgement which is sent by the processor after INTR is received. So there are several kinds of pins are also available, which are basically representing the interrupt pins: RST 7.5, 6.5, 5.5 and trap. So these are the basic interrupts. So trap, among all of the interrupts, trap is the highest priority interrupt, and the locations from which the next instructions is picked up. The locations of the trap is 0024, and after the trap, the next highest priority interrupt is RST 7.5, and the vector location 003C, then RST 6.5, and the location is 0034, and then RST 5.5 whose location is 002C. So RST 7.5, RST 6.5 and RST 5.5 are the restart interrupts. Okay, they cause an internal restart to be automatically inserted. Each of them has a programmable mask, and among all of these interrupts, the trap has the highest priority interrupt, and INTR, which I have already discussed, this is the lowest priority interrupt among all of these interrupts. And there are some other pins are also available in Intel 8085 processor. They are basically called the serial input output pins. One is called SID, which is called the serial input signal, and another one is called SOD, serial output pin or the serial output signal. SID means it is the data line for serial input. That means the data on the line is loaded into the 7th bit of the accumulator, okay, by using particular instruction which is known as the RIM or the RIM instruction. And SOD, which is the output pin of the processor, is used for serial output, and the 7th bit of the accumulator is output on SOD when SIM or the SIM instructions is executed. Thank you.